3.1, the title of the section is literally called just definitions. So that's what we're basically talking about, is just defining some important things that we'll use for the rest of the chapter. We're pretty much talking about parallel lines, parallel planes, things like that, some relationships between those things. Okay, so lines that do not intersect are either going to be parallel or skew, and we'll talk about what skew means in a second. That one might be one that we have not heard of as much. So parallel lines, if lines are parallel, then they are coplanar lines that do not intersect. One of two key things they're being, they are coplanar, so they are on this, they're both on the same plane, the lines would be, and they do not intersect, so they're never going to cross each other, right? So if we look at this diagram here, just a rectangular prism is sometimes a nice picture to look at for this, because there are a lot of parallel lines in this picture. Who could maybe identify one set of parallel lines for me? Anne-Marie? Line CG and line DH. So CG you said, right? CG, yeah. Oh, that looks bad though. Line CG and DH. I think it's glitching. Something bad's happening because I'm not drawing that cricket of lines. Yes, those would be parallel, and then we have a certain way that are there any others that are also parallel to those? Yeah, a bunch, right? AE would also be parallel to those. BF would also be parallel. Okay, so I think parallel tends to not be an issue. We tend to understand what parallel is. If you were to write this, there is a special symbol for parallel. So we would say that line DH is parallel to line CG. So you use this little, it actually looks like two little parallel lines, this. That is your symbol for parallel. So those lines would be parallel. Skew lines. If lines are skew, then they are non-coplanar lines that are neither parallel nor intersecting. So this time with skew lines, they cannot be on the same plane, they will not be parallel, and they will not intersect. So I'm going to kind of give you one example and then see if you guys can identify any more. So one example of skew lines would be line AB with line EH. Line AB is either on that top plane, right, or on that left-hand side. Line EH is either on the bottom plane or the front of your rectangular prism. Are those ever going to intersect each other? No way. Are they parallel to each other? No way. Are they in the same plane? Nope. So that is meeting all of our qualifications for skew. Something else I kind of look for is that they're never really going, because they're not parallel, they're never really going the same direction, right? If one's going left, right, maybe the other one's going front to back or something like that. So this would be one example of skew lines. So I'm going to say line AB, and there's no symbol for skew. We would just list that they are skew. And line EH. This would be one example of skew lines. Does anyone see another set that could work? Anne-Marie? BC with, I'm sorry, could you repeat that first one? DH, yep. BC and DH would also absolutely work. Good. And there's a lot of different examples. I just wanted to name a few. And line DH, good. And then we also could have parallel planes. If planes are parallel, then they just simply don't intersect, which we actually have several sets of parallel planes in this picture, right? The top and the bottom of your box, the front and the back, the left and the right, etc. And we can kind of show that in the same way as we show parallel lines. So if I wanted to say that like the top and the bottom of my box were parallel, then how I would write that is, remember when you name a plane, pick at least 3 points on it, at least 3 non-collinear points on it to name it. Is it okay if it's like a picture like this? Can we use all 4 corners to name the plane? Yeah, that's okay too. Sometimes that actually makes it a little easier to identify, especially when it's like a rectangular prism picture like this. So if I wanted to say the top of my rectangular prism was parallel to the bottom, I could say that plane A, B, C, D is parallel to plane E, F, G, H. And remember, there's no symbol for plane. Just having those letters together like that implies that it is a plane. Okay. And there's, again, several different examples of that. Additionally, a line and a plane can also be parallel if they never intersect, right? Because your plane is going to extend forever, and so is your line. So for example, but something also to remember with a plane versus a line is only going to extend forever and ever in 2 directions, right? Maybe left to right, front to back, things like that. But your plane is going to extend over a flat surface forever. So one example here of a parallel line with a plane could maybe be the bottom of your rectangular prism and maybe line CD, right? Are those ever going to intersect? No, right? Lots of examples, that's just one possibility. Or maybe the left-hand side of your box, plane CD, I can't talk, DCGH with maybe line AE. Right? Won't line AE continue up and down indefinitely? And then plane DCGH is going to also continue up and down and front to back forever, right? So there's a couple different options with that. Any questions about our vocab so far? Pretty simple so far, straightforward. Okay, great. What time are we getting out of here? Can you read that, Joy? 56. Okay, perfect. Thank you. All right, theorems. We just have one theorem. The theorem is the parallel planes theorem, which you can see on page 74 in your textbook if you'd like. There's a proof for it and everything. But with I didn't get that. Could you try? I wasn't talking to you, Sarah. But if I didn't worry about the proof for this one just because class was so short and there's no proofs in your homework tonight. But this parallel planes theorem says if 2 parallel planes are cut by a third plane, then the lines of intersection are parallel. So envision if you have 2 parallel planes, right, like maybe one plane above another plane, and there's a third plane slicing them vertically. That's one example, right? Your 2 planes are going to intersect to form a line, won't they? So it's saying that those lines where they intersect would also be parallel because the planes are parallel. And there's a really good diagram of that on page 74 in your book if you wanted to take a look at that. That one's not used as often. It's just good to know about. Then a few other vocab words. These are going to follow us along throughout the whole chapter. First one is a transversal. If a line is a transversal, then it intersects 2 or more coplanar lines in different points. If you look at our diagram here, our transversal is line T. Line T is intersecting line H and line K at 2 different points, so that would be the transversal. So this would be line T. I'm using a little weird cursive T. So that would be an example of a transversal because it's intersecting those other 2 lines. Then we have a few, these are like angle relationships that happen when you have situations like this, when you have lines and a transversal is cutting them. Some special angle relationships are going to occur. Today we're more just focusing on identifying them, but then throughout the chapter we'll be talking about which ones are congruent versus supplementary, using their measurements to find other things, doing proofs with them, stuff like that. So the first one is called alternate interior angles. What's kind of nice about them is it describes exactly what it is in its name. So alternate interior angles. If two angles are alternate interior angles, then they are non-adjacent interior angles on opposite sides of the transversal. So if you were trying to identify alternate interior angles, I would look first of all for your transversal, right? And it says that they are non-adjacent. So like 1 and 3 here are adjacent. That would not work, right? And it's saying they're on opposite sides of your transversal. So in this situation, your transversal is kind of going, it's not a completely vertical direction, but like a down to up direction, right? So your two angles, if they're on either sides of that, one's going to be on the left, one's going to be on the right. Another important thing and we'll pick out a few pairs in a second, but notice here how it says interior angles. It's going to be important to be able to distinguish between interior versus exterior angles in these pictures. Interior angles are literally the angles between the lines that are being cut by the transversal. So if we're referring to our interior angles here, we can make a little list. So our interior angles are the ones, again, between the lines being cut by the transversal. So that would be angle 3, angle 4, angle 5, and angle 6. Those would all be interior angles. Does that make sense? Yes, okay, excellent. Then conversely, 1, 2, 7, and 8 would be exterior. So if we're talking about alternate interior angles, that's all we have to choose from. So then just pick ones on alternate sides, right? So what do you think could maybe be an example of alternate interior angles, Carly? Exactly. Angle 5 and angle 4. What else could work? Melissa? Angle 3 and angle 6, exactly. Perfect. Good. Then we have same side interior angles. So we had alternate, right? Now these ones are still going to be interior, but along the same side. So if we're not doing alternate anymore, what do you think could be an example? Oh, let me, I guess, read it to you first. If two angles are same side interior angles, then they are interior angles on the same side of the transversal. So which ones would that maybe qualify for, Maya? Angles 3 and 5, good. What else could work? Carly? Angle 4 and 6, good. Good. And then last one, corresponding angles. If two angles are corresponding angles, then they are two angles in corresponding positions relative to the two lines. Not a great definition because it uses the word in the definition, but it's the one your textbook uses. So I went with it. So what actually ends up happening with corresponding angles is when it says they're in the corresponding positions, they mean like the same relative position, okay? So if you have two intersecting lines and you're looking at one that is on the left of the transversal and above the line that's intersected, then the other one is also going to be on the left of the transversal and above the line that was intersected, and vice versa. It just, there's not a great way to describe it because your picture can really look like anything, right? This picture could be turned to the side, there could be more lines happening. But so for example, if I wanted to look for some corresponding angles, angles 2 and 6, I highlighted those backwards, but 2 and 6 would be corresponding angles because they are both on the right-hand side of the transversal and they are both above the lines that are being intersected. Does that kind of make sense? Okay. So that's just one example. This one actually has a bunch. So we'll list 2 and 6. Any other ideas of what could work? Melissa? Angle 3 with angle 7. Very good. Those are both on the left, right? And then below the line that's being intersected. Good. So angle 3 and angle 7. Any more ideas? This would actually have 4. Ayla? 1 and 5, right? Both to the left and above. Angle 1 and angle 5. Where would the last one have to be? 4 and 8, exactly. Good. Next part, just examples. Okay, so you'll notice this picture is a little different. There's some more lines happening. So in this situation, which one is the transversal depends on which angles you're looking at, right? So for example, if I ask you to look at angles 5 and 10, these blue lines would be your lines that are being cut, and then this red line on the left would be your transversal, right? If you look at it maybe then going the other way, like if I asked you to look at maybe angles 15 and 14, your blue line on the bottom is your transversal, and then the red lines would be the lines that are being cut. So there's, you have to kind of change your perspective depending on which angles you're looking at. I want you guys to try this one out. Classify each pair of angles. First one we are looking at is 7 with 11. What did we say for angles 7 and 11? Maya? Yes, those are same side interior angles. Good. Brock asked if we can abbreviate. Absolutely. I would probably do like oh my gosh, what is happening? SSINT for this. Don't be dead. Why are you dead? My stylus is dead. Lovely. SSINT. That'll work. Okay. Angles 14 with 16. 14 with 16. What did we say for those? Corresponding 14 with 16. Yep, absolutely. Those would be corresponding. Don't really know a good way to abbreviate corresponding, so that's what it's going to be for now. Pick something that works for you. As long as I can tell what it is. I'm not picky. Angles 3 and 6. Melissa. Yep, those would be alternate interior angles. Good. Angles 5 and 10. Okay. I'm ready, Brock. Yes, these are also alternate interior angles. Good. What about 2 and 10? Anne-Marie. Corresponding. Good. And if you got one wrong, just fix it. And 6 and 7. Same side interior. Good. Good. Questions on those? We feel pretty good about identifying them? Good. And if you guys ever feel like you're struggling, let me know. I have a few little tricks for them, but I feel like we should probably be okay. And then we just have a quick always, sometimes, never. 2 lines are parallel, or 2 skew lines. I'm sorry, 2 skew lines are parallel, always, sometimes, or never. Melissa? That is never. That is in the definition of skew. They cannot be parallel. Good. 2 parallel lines are coplanar. Always, sometimes, or never, Maya? Always. Parallel lines are always coplanar. Good. 2 lines in the same plane can be skew. Always, sometimes, or never. Never. Why never? Very good. Yes, in the definition of skew, it specifically says skew lines are not coplanar. Good. And then if two lines are parallel to the same plane, then the lines are parallel to each other. So if you have a plane, you have two lines parallel to it, do those lines have to be parallel to each other? Reagan? There would be sometimes. Very good. The reason that one would be sometimes is if you have a plane, right, it extends on a flat surface. And for lines to be parallel, maybe one is going front to back, right? But maybe one's going left to right. They'd still be parallel to the plane, but they wouldn't be parallel to each other.